Well, we're skipping around a little bit in the book. We're going to go straight to 6.5 now, where there's an application of integration, and it'll mean setting up integrals. And this is called the average value of a function. So, here's an example. If you want to know the average temperature over a day, 24 hours, you can take the temperature, like watch the thermometer and graph it, and the thermometer will wiggle up and down, but it'll basically have that interesting little curve, on a normal sunny day where it gets low and then high. All right, so one way to get the average would be to sample it. So you could measure the temperature every 3 hours there, like at hour 3, 6, 9, 12, 15, and so on. And then here's how you find that average. You find the temperature T of 3, that would be the temperature after 3 hours, at 6 hours, 9 hours, 12 hours. Dot 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 means just keep going at that same distance every time, up to temperature at 24 hours, and add them all together and divide by 8. And you can see there's going to be 8 measurements there if you count them by hand. We can also calculate the number of measurements by dividing by 24 by 3, because if you measure it every 3 hours, starting at the 3rd hour instead of at 0, then you'll have 24 divided by 3 equals 8 total temperatures. So you could call the 3 the change in x, since that's the difference between every measurement. And we call 8 n the number of measurements, or number of data points. All right, so if you want a better measurement, you can put in more data points. So how about every hour? T of 1, T of 2, T of 3, all the way up to T of 24. And then obviously then there's 24 divided by 1 equals 24 data points. Even more, how about every half hour? Now it's T of 0.5, T of 1, T of 1.5, all the way up to, that's supposed to be T of 24 again. Need to put an extra 4 on the end of that. So if that last one is T of 24, then there's 48 total measurements, which you can tell because it's every half hour. Or if you wanted to figure out how to calculate that, you'd take the total amount of distance or time here and divide it by 0.5. And that, when you divide by change in x, divide by 0.5, that's like times 2, so you get 48 as the n. All right, so now we can turn that into a formula, which would be a big sum. Big sigma means the sum. That says from I equals 1 to n. A little hard to read, but the standard sum, I equals 1 to n. And then you find the temperature. So the temperature that you find is at the time 0 plus, 0 is just the starting time, so I just put it in there. And then the number I, that's the one that goes 1 through n, times the total distance, which would be the biggest hour minus the 0 hour, divided by n. So I put all those extra zeros in there because sometimes you don't start at 0. Sometimes you just want to find it from noon to midnight. So the starting time is the 0. The I is the number of measurement where you go from 1 to n. And the 24 minus 0 divided by n would be, that's the size or the amount of hours that have passed for each of the I. And 24 minus 0 divided by change in x, that's the total number of measurements that you get. All right, so, which should come out to being n again. So, but I wrote it in that funny way because I'd actually like to keep it like that, because I want to break it up. I want to take that change in x, and since it's a complex fraction, you can flip it over and write the change in x on top, and then I pull out the 1 over 24 minus 0, and keep the rest of the sum the same. And you can figure out what the change in x is. It's the b minus a over n. That would be the 24 minus 0 divided by n in our example. And so now, if you remember Riemann sums from Calculus 1, this starts to look like an area. It starts to look like the area under a curve. So here's how you do that. For any function and letting the number of data points go to infinity, you can write the following. The real average of f of x over the interval from a to b. So this would be the true average where you have an infinite number of data points. Well, that means I'm going to need a limit as n goes to infinity. So I do pull out the 1 over b minus a, that's the total distance or time or whatever you're measuring. I can pull it out front of the limit. And then I equals 1 to infinity. I have that b minus a over n, that's the change in x, depending on how many n, how large n gets, the number of data points. And then the function, I used temperature before, but in general any function f is a plus I times b minus a over n. That's the starting point plus the distance that you've gone so far as I goes from 1 to n. And that limit is exactly the same value as the integral. So all of the limit of the sum turns into the integral from a to b f of x dx. And now we have a formula for the average. It's 1 over b minus a times the integral a to b f of x dx.